So today I'm going to discuss the second module of Episense Comprehensive Epidemiology and Biostatistical Software, specifically designed for the public health specialist and and those who are working in the field of medicine to understand the concept of different biostatistical and epidemiological things that is required for different research. So today I'm going to discuss about the second module, which is statistical concept visualization. So in this particular statistical concept visualization module, we will be able to understand that what is population, what is sampling, what is central limit theorem, then different type of distributions, different skewness, kurtosis, and a standard normal curve. So in the first submodule, that is population sampling and central limit theorem. So to understand it intuitively and visually, so first let's generate a population. So from minimum value 0 to 100, or you can change it based on your requirement. So from population, you can write from 1000, 10,000 based on your will. So first, whenever you will generate the population, so you will get the population and the distribution. Next, from that population, if I want to draw some sample, so I can select the sample size from 30, 40, 50. So let's start with 30 or let's start with 40 as per your choice. So now let's see. So I can draw sample once at a time, or I can draw sample 10, 20, 30, 40 at same time. So based on my wish. So I choose to draw sample once at a time. And I want confidence interval of 95%. You can also select 90% or 99% based on your will. So let's try to understand. So first draw a sample. So whenever I will click, so from that distribution, so these are randomly selected samples from the population, and this is the sample distribution of the first one. So from the first one, what we get, so it is the population and that sample, and I can get the sample bound of 90% confidence interval, 95 and 99% also, and I can also get the sampling mean and its particular for the first sample, the sampling mean and its distribution. Now let's try to understand. So then draw the second sample. So this is the value, and this is yes. So this is third sample, first, second, third. So this is fourth, fifth. So based on that, I can draw multiple such sample. So let's try to draw such samples. So yes, number of samples, how many? We can get it here. And now, based on that understanding, so let's draw different samples and their distribution is here. So now this is the actual drawn sample for the last, how many samples I've drawn. So it's one, two, the number of samples is basically I till now developed up to 17. So their sampling mean and their sampling distribution. So everything is there. So to understand that different concept from population mean to standard deviation, sample distribution, then sample standard deviation, standard error, then what is confidence interval and what is central limit theorem. From that, so we can get it. So now you can also find here something called heat and something called means. Means whenever that sampling in the sample, that it is within that 95% confidence interval, the mean, it will called heat. And if it is means, it is bound beyond that 95% confidence interval at the any side. So it will give you as a means. So this is the understanding of how from a sampling standard deviation, sample standard deviation and standard error, we can calculate and their understanding how to use it. You can get it intuitively able to understand from how from population to sample and what is the requirement. So without understanding the entire population thing from the sample also, we can estimate different population parameters. So now try to understand different distributions like normal distribution, student distribution with their equation, the chi-square distribution, and then different binomial distributions, and then Poisson distribution, log normal, exponential. So you can also change the different number of trial, probabilities of success. So based on that, you can also check different type of distributions and different type of their understanding. Okay, so like to get it that distribution and their how different shape changes based on the change in the different parameters. So now come to the different what is known as the skewness and the kurtosis, then how left or right it is shifted the tail, and also that how picket it is. So based on that kurtosis is there. So you can get intuitive understanding how that if a normal distribution, if I just a small outlier it we added, which is a very small one from the other sample. So how it is left-handed distribution, and if it is you use a very large number, so then how much it's deviate from the their skewness. So based on that, so right skew, left skew, you can able to understand based on the distribution. So now, yes, so these are the understanding mean, median, and how that skewness, positive skewness or negative skewness, this thing. So then come to understand of the kurtosis. So it is the picket. So yes, you can change the parameters to understand how it is. It is pleticotic, means it is flatter than the normal. Then if it is the extreme one, that is that is the highly leptocotic, which is the more peaked than the normal distribution. So understanding of different type of kurtosis, mesocotic, platicotic, and leptocotic, and you can visualize it and you can understand this concept. Now come to the understanding of the standard normal Z score. Like if we want to compare different units, like in case of height in centimeter and inch, if we want to compare them, so we have to make it some standardized. To standardize that, we can do it the formula by from the standard deviation to make it a standardized one to comparable, to make them comparable. So now let's try to, so this is the a mean and standard deviation. So if you change that, you can, that mean and standard deviation also change. And if I want to standardize it, I can do it automated. So that's why I have add that particular automorph animation. So now let's see how it's become it's standardized. Okay. So now this is the standard normal, and from the Z score based understanding, just understanding of Z score. So one standard deviation, how much curve area of that normal distribution curve is there. Then one standard deviation, two standard deviation, three standard deviation, and for any given point, so what will be the exact Z score? You can also get it from that standard normal curve. So this is the second understand. This is the understanding of the second module. That is the different statistical concept visualization for the beginners. And in the next video, we will discuss about the sample size calculators. Thank you.